Well, it's high time we speak about football. Not the results of the recent matches, but how artificial intelligence is applied in this sphere. We understand that ladies are leaving the room, but we will discuss this thing with men. So, football, guys, is a large mass of data, trajectory, speed, tactics, and a lot of other metrics can be analyzed with AI. Simeon Budionny, Managing Director, Development of Promising Technologies, AI4Sport, and Evgeny Shevelyov, Deputy CEO on Sports in Professional Football Club CSKA. They will speak about how artificial intelligence is changing football today, from analyzing matches and preparing the players down to interaction with the fans. So, Evgeny Shevelyov, Simon Budionny, the floor is yours. Hello, hello. So, can you hear me? Is it okay? Very good. So thank you very much for your introduction. As it was properly said, the presentation is not only made by me, but Zhenya, my colleague, he will join me a bit later. So we split the presentation into two parts. I will try and answer the question how, what algorithms we apply in analyzing football matches. And Zhenya will speak about why and what AI can give us in football and what it gives today. So we'll be moving in this type of logic. I think that it's not a secret for you that in sports, computer vision is working very efficiently, and this is a commodity actually. Fine-tuning the current model in sports. It can be team sports or individual sports. Football, we are talking today. This is a commodity from one hand. From the other hand, all details, the devil is in the details. And when you start applying, when you go to inferences, and it should be cheap, and we should have solutions that are operating in an online mode, we should not only think about accuracy, but the efficiency of the implemented algorithms. On the slide to the left, we are showing a case, and Zhenya will give you more details about that. We are tackling the task of detection. We should see the football players and the ball and split them into teams. And homography is another task. All footballers should go from 3D to 2D, and we need to understand the coordinates of the players, their locations, to tackle the tasks phase 3 and 2. In post-analytics, we should extract useful information for the club, for the football professional club. And we need to understand who plays and what type of game and what phases there are. And in this analytics, there are not many open publications on that. And the main partner for us in this area, CSKA and AIJ Institute, we're focusing mostly on these points. And some of the cases I will try and touch upon in my presentation. So post-analytics, we are preparing after watching matches from one camera. It's very important, by the way, because you can go through sensors. All footballers can wear sensors, and you can track everything with good accuracy. But we have a more challenging story here. We wanted all analytics from one camera, and our task in the future is to scale it not only for professional clubs, but cases in the regions. We do not always have all the equipment, including sensors. It is too costly. That's why we are taking as much as possible from one camera. And as a result, we should have a report. We show the gist to the right. The report is prepared by GigaChat. We receive all the analytics, and sometimes we even use vision and perception models. We can recognize some of the charts through vision models, and we prepare the report through prompt engineering and using the data from post-analytics through professional marking in LaTeX template. We can see the information about the game. Homography task, we need to articulate the basic zones. To tackle the projection task, we need the reference points. It turned out that this task is of noisy nature. In order to project well, we need to see the basic points clearly, but sometimes it's a challenge to identify them. And we had to additionally train models and make more markups. Mapping. We're interested in scaling. If we go to a different field, these reference points can be changed, and weather can also impact. This is a challenge indeed. So we need to have a lot of such basic points to actually mitigate this noisy effect. And then we are detecting, and I mentioned that already, and then we can have real physical characteristics that can be also obtained manually, but that might be too costly. Physical characteristics, the speed of the players, the speed and the stamina as a result of important parameters for selection and scouting, but it's a simple thing. But physical characteristics is not the key indicator in sports. So a football player might not be the fastest or hits the ball harder than others, but through tactics, he can be very effective on his team. So these are the characteristics we're looking at, but not the key ones. More interesting characteristics, heat maps. We can track our team and the opponent team, and that's the case we want to apply. Making decisions in 15-minute break to see what zones are covered by what players. We can see it in statics and dynamics. And we see topological logic in these zones when we analyze it. When we speak about football, by the way, the task is interesting because it is covered by all modalities. We have video as an input and we process it as video modality, but other representations that show us more interesting insights are as follows. Topological analysis, because the quality of the game is defined structurally wise, how players interact and link to each other. Topology analysis helps us. Persistence homology calculation, for instance, but our experience shows, but it doesn't give us much insight. Graph representation is the second representation. Looking at the game as a transport graph, we can tackle the task of the best combination of the logic of the play. Then tokenization. For instance, we can go to discrete representations. We can define all actions of players through the list of tokens and use the NLP approaches with the transformers and all. Now we can predict some of the events, but this task can also be tackled through tokens. If we tokenize the whole game, we can use NLP approaches. I should say that tokenization of the game also allows us to tackle such tasks as commenting. So we can comment all the actions of the players in the match in the way professional commentators are making it. So, and we add the voice, and yes, this is a solution. We can also make stories like that. This is useful information for analytics, for scouting, when making decisions on buying and selling players. This can be done automatically. So, another very interesting task. It is small but very important. We show that we can predict the probability of the passes. Yes, there is much data, but intuitively it is not obvious that you can F1.0 order can give us the predictability of the interaction between the one with the ball and all other players around. So with good accuracy, this model can be trained, and we did that. And it turned out that in featured potence, the actually pass success is pressure over the one who is with the ball and the one who is receiving. So this feature this feature is geometrically interpretable. We calculated it with the representation, special type of Voronoi representation. This is not rocket science. But the key thing is to extract useful information. So two teams are here. One is in red, the other is in blue, and the zone of influence is around every player, and the pressure with geometric interpretation can be interpreted as the diverse with the space of influence. So the more players from the different team are around you, the more pressure you have. With the ratio, knowing how many players of what teams you have around, and dynamics is important for us, not statics. It is important not the area, the zone of your influence and the pressure, but how this pressure is growing. That's why we think, that's why we are calculating the derivative. And with a short period of time, we see with the blue zones, with the blue curves, we see the passes zone basing on the pre-trained model. If we can calculate all the combinations possible, we can tackle this task with transport graphs. The transport graph task between point A and point B, minimizing not the time parameter, but maximize the multiplication of probabilities. If we have probability from A to B and then we have C, we want to maximize, and to have the right to use Dijkstra algorithm on transport graph, not modifying it. We modify the sum minus the logarithm of probability, and to get away from the problem of bias. So we look at dependent events. From classic statistics, in the theory of relativity, we know that the two events can be multiplied if they are independent. But the combination of passes, these events are interdependent. And to get away from it, we're tackling the task of predicting who will go there, who will run there, to have to be able to predict and be able to multiply these probabilities. And I would like to finish with the last answering the answer how. I will finish with the case which is under work now. Very interesting one. So I fix a cell. I say that the pressure is also is linked to the zone, and the amount of opponents around me is important. And another case quite interesting, that is coming out from the diffusion theory. We have pressure for diffusion or for the equation for the pressure and the space, and we have the alpha ratio coefficient that can be interpreted as the coefficient ratio of permeability. Using the diffusion equation for empirical data, we can identify the alpha coefficient that will show us how one football player having its zone of operations can go through other cells, giving opportunities for his team and simplifying his life. So in football matches, we analyze not only the one who is with the ball, but all the others around and how efficient they are in creating more opportunities. And this is defined by how they can go through high pressure. And this can be seen in physics, and there are a lot of analogies like that. And this is a separate, very useful feature. Data science can be used, but feature engineering is more important for us, for such physical and geometrically interpreted characteristics, to take it from football and then train models on this data. So these are the characteristics we can show with the time. Nothing new about that. I think with this case, I would give the floor to Zhenya. Probably I was too focused on algorithms and maths, speaking about how, through mathematical lens, how we look at football games, but how it can be applied in real football club. That's the theme of my colleagues' presentation. We are making this project together with them. Zhenya, the floor is yours. Thank you very much. This is it from me.
Good afternoon, friends. I'll start with some platitudes. Football is a very simple game, but it's so hard to play football in the simplest way. And when you hold the ball, you need to know what to do next. It doesn't matter what happened before. how many kilometers was run by him, what he's going to do next. This is what matters. Either he would pass to player 3 or player 4, or intermediate pass to player 2 and then player 3. And resolving that is key for our project. So we need to know which would be the option that the player opted for that aggravated the attack and made it more intensive with higher probability of other passes. And this is what we assess at each second of time, whether the decision was an optimal one or not. It is also important to know what the player was doing, not holding, not having the ball when he receives no passes. He can make any movement that would free him from pressure and make all the play of the team more aggressive. So we also assess the players' decision-making when they don't hold the ball. So the game with the ball and game without the ball, this is a combination of two factors that we take into account. If a player is effective in both, it is one of the best players, and he would endure the entire season without problems. So analysts have to work with that, and we tried to subdivide the game into episodes, different types of attacks and standard actions in order to summarize matches so that the coach or the team manager can know what was done in a good way and in a bad way. So in this Giga chat helps us receive insights about the game without analyzing a huge number of tokenized events. Moving quickly to the insights, this is what our stakeholders are after. I mean the management. So and this gives us an idea of the track record of each of the soccer player, whether they approximate our victory or the victory of the opponents. So we'll look at amateur players and school players and schools in Tobolsk, Yuzhno-Sakhalinsk, selecting someone for future, trying together whether the actions of these players are in line with what we expect from them. So football is a spectacle for fans. So smart graphics reminiscent of FIFA would help you give out video reports generated automatically with the help of Kandinsky. This is probably what our managers love most. They can see a beautiful picture, which is quite obvious. For each of the discrete events, we have the context and the description and the variations, how to play and where to pass and what the player decided at the end of the day. We test that with the CSKA team in combat mode and in youth matches and selection matches, so that we can analyze any match in the world without using sophisticated technological devices, so that our team can become the leader in the championship, #1 in the championship. Thank you, Eugene. I still have a question. Let me ask it. Probably you said a lot answering that. On that topic, how can AI change the strategy of training football teams? Well, thanks to a more detailed understanding of the issues about the decision makers of the players, we can build individual trajectories for the athletes in our team. And if we speak about big data, we would have a better selection process. And previously we could not automate all that. Thank you, Eugene, for a very interesting presentation. Yevgeny Shevelov and Simon Budony.